All right, so let's look over the questions from the Test 3 review. So in the first question, I ask you to sketch f of x equals 5 to the x power and g of x equals log base 5 of x. And notice that of these two, I think we're probably more confident graphing the exponential function, right? So we're going to start there. So when you want to know what a graph looks like, you can always do an XY chart. So we're going to pick some x's that are both positive and negative, and we're going to plug them in to the squared equation. So this is going to give me 25. 5 to the first is 5. Anything to the 0 power is 1. Remember that negative exponents give us fractions, so that's like 1 over 5 to the first. And this is like 1 over 5 squared, so it's 1 over 25. So when I graph that, and I'm going to go ahead and put up a review because I didn't bring another set of graph paper with me. So when I graph that, I would get the 0.01, right? 1, 5. Notice 225 would be really hard to mark, right? But it does tell me that, hey, I'm going to go up super sharply here. And then -1 and -2 are getting closer to 0 without actually truly touching 0. So this would be f of x. Okay. Notice, though, that we have these two graphs, right? And notice that these are inverses of each other. Exponents and logarithms are inverses. So what that means is, actually, I can just swap x and y. And that's going to be a much easier way for me to come up with my set of points than it will be to try to rack my brain and figure out what the logarithm value is at each spot. So notice all my x's become y's. All my y's become x's. And then I'll just graph those, and I'm going to go in a different color. So 1, 0, 5, 1 would be here. 25, 2 just tells us that, hey, this is going pretty sharply this way. And then I've got 1/5, -1 would be about here-ish. So notice instead of getting close to the x-axis as we did with the blue graph, now we're getting close to the y-axis. And by the way, these are perfect reflections of each other over the line y equals x. Okay, so all exponential graphs look like this, look like the blue graph. All logarithmic graphs look like this, but the steepness might be different for both. Okay, so if you were going to graph, for instance, 3 to the x power, it would look like this graph, but it would be less steep since 3 is smaller than 5. If you were going to graph like 8 to the x power, it would be steeper because 8 is bigger than 5. And same thing here. If you were going to graph the log base 3 of x, it just wouldn't quite go up as far, or actually it wouldn't go quite out as far, right? So it would go like about to here. So it would just be a little bit different steepness, but have the same general look. Okay. So keeping those things in mind, let's look at number 2. So if we know what the graph of log base 5 looks like, then what happens if I add a 2 on the inside of the function? Okay, so this is part A for number 2. Well, what happens is this indicates that I need to shift left 2. Remember, it's an inside, so it's left or right, and it works the opposite direction of the sign. And then, last but not least, what about negative log base 5 of x plus 3? Okay, so the first thing that would happen is because of this negative sign out to the front, it would be a reflection over the x-axis. And then this plus 3 on the outside would shift it up 3. Okay, so remember we have 6 total transformations, so we can talk about horizontal and vertical shifts. We can have reflections over the x and y axes, and then we can also have vertical stretches and shrinks or horizontal stretches and shrinks. Okay, so make sure you know kind of the 6 transformations and what those look like. All right, so number 3 and 4 are kind of opposite problems. Okay, 1 starts off in log form, and I'm asking you to rewrite it in exponential form, and then number 4 is vice versa. So you just need to know kind of where things go here. Okay, so for number 3, you would say that 9 to the 2 power equals x. Okay, because here was the original, right? 2 equals the log base 9 of x. So the base of the logarithm becomes the base of the exponent. The answer to the logarithm is always the exponent, and then the other value goes in the other spot. Okay. So notice I could say that x is 81, but I didn't really get asked to solve for x. I just got asked to rewrite it, and I already did that, so I'll just circle that part. Number 4, on the other hand, shows you an exponential statement, and it wants you to rewrite it as a log. So we're just going to do backwards of what we just did. Okay, so it's going to be log base 2 because the base is 2. Remember that the answer to a logarithm is always the exponent, and then the other number has to go right here. So it's almost kind of like this to this power equals this. I go kind of out of order there, and that's usually how I keep my details straight there. So for number 5 through 7, that's essentially what you're being asked to do. You're being asked to rewrite it in a term that makes more sense. Okay, so what this is really asking you is, what do I need to raise the 3 base to the power of to give me 1 over 27? Okay, now the answer, notice if it were regular old 27, it would be 3 cubed, right? Because it's a fraction, remember negative exponents give us fractions. So the answer then will not be 3, but actually negative 3. Okay, note this is your reason why, but this is actually your answer. Okay, so on the test you need to make sure you circle or hone in on what your answer is. Don't just write me a statement like this and not tell me which part of it is your answer. So same kind of thing on number 6 and 7. So this looks weird, but when we rewrite it and realize what it's really asking us for, it's not as bad as you might think. So this is saying, what do I need to raise 6 to the power of to give me the 4th root of 6? Okay, and of course, roots give us fractional exponents, so since it's 4th root, it's going to be 1/4. If it were cube root, it would be 1/3. If it were square root, it would be 1/2. Okay, so remember, fractional exponents give us roots. And then last for this set, log base 41 of 41 equals what? So this is really asking, what do I need to raise 41 to the power of to give you back itself? And notice the power you would need is 1. So kind of a principle being used here that it'll be really helpful if you know for the test is the answer to a log expression is the exponent. That's what you're being asked to find when you're asked to find the log of something. Okay, so notice all of our answers in the past 3 problems were what was in the exponent spot. Okay, so let's look at number 8. So starting with number 8, we start looking at the rules of logarithms. There are 3 rules of logarithms. So let's write them down. So the laws of logs are as follows. Let me slide it over a little bit. We have product rule. We have quotient rule. And we have power rule. Okay, so all of the rules for 8 through 12 really is all going to use some form or combination of those rules. Okay, so let's take that into account. So let's look at number 8. So the log base 5 of 125 over y. I'm going to put a parentheses there. Okay, so which rule would we use? Well, clearly we are dividing, right? So we would use the quotient rule. So this is going to give us the log base 5 of the top number. And then the quotient rule says we subtract the 2 logs when we expand them. And then I want you to evaluate any part that you can, because this can actually be determined. Okay, remember the answer is the exponent, right? So what this is saying is, what do I need to raise 5 to the power of? That would give me 125, right? and 5 to the third power is 125. So the answer fully simplified would actually be 3 log base 5 of y, or minus log base 5 of y, I mean. So notice, I can't really do any simplification here because I don't know what y is, but I can simplify log base 5 of 125, so I want you to simplify any part that can be worked out. All right, so let's look at another one. Notice the rules say to expand it, right? So we're supposed to pull these apart into separate log terms. So this is going to look like natural log of x cubed. Notice we are multiplying, so that would be product rule, which says we can pull them apart by addition. But then we start dividing, and notice it's actually divided by both of these things. So both of these things are going to be negative. Also think of it this way. Negative exponents go on the bottom, so parts of the logarithm that are negative also go on the bottom. Okay, and then last but not least, if we want to expand this, is we can actually use the power rule that says that you can move these terms to the front of their individual pieces. So fully expanded, and really as far as we could go, it would look like this. Notice I'm not going to do anything with the natural log of 8 because I don't know what power of e I need to raise this to give me 8, right? Notice that the understood base for ln is e. So there's nothing really we can do there. Remember, e is that number 2.71828, blah, 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 right? So I'm not going to be able to do anything with that. So that would be it. Probably the toughest one in this little section is number 10. So this is the log base 2 of the cube root of x y to the 4th over 16. So we had one kind of like this in class if you were there that day, but this is log base 2 of x y to the 4th over 16 to the 1/3 power. Okay, because cube root means 1/3 power. And then I can just actually make sure that everything gets the 1/3 power. So this would be the log base 2 of x to the 1/3, y to the 4/3, and then 16 to the 1/3. Okay, so notice this 1/3 kind of got distributed here, here, and here. So now I can do kind of like I did the problem before. I can pull these pieces apart. So it's log base 2 of x to the 1/3 plus, because both of these are on top, log base 2 of y to the 4/3. And then minus log base 2 of 16 to the 1/3. Move that over. Let me zoom out a little bit so we can see all of it. Of course, it doesn't want me to zoom out. That's as far as I can go with it. Move this up a little bit. I think it's a little bit better, not a ton. Okay, so the next step is if we're trying to fully expand it, we need to move all of these exponents, as weird as they may be, to the front of their pieces. So we get 1/3 log base 2 of x plus 4/3 log base 2 of y minus 1/3 log base 2 of 16. And then last but not least would be to see if I could do anything with this guy. And I think I can, right? Because this means 2 to the what equals 16. Okay, so what power of 2 gives me 16? And the answer is 4. So the final answer would just be 1/3 log base 2 of x plus 4/3 log base 2 of y. I can't really do anything with those because I don't know what x and y are. But here I would get 1/3 times the 4 that I got here, so it would just be 4/3. Okay. So really make sure you know how to process those 3 rules, product rule, quotient rule, power rule. So the next couple questions have you do the backwards of what we just did. Okay. Notice in 11 and 12, I give it to you in expanded form and I ask you to simplify it. So you just go backwards, right? So this could actually move back to the exponent spot. So the first thing we could do is write that as x squared Remember, you're going to want to make your z's something different than your 2's so that you don't get them confused. And then because of this plus sign, this means product rule. So if we combine them together, we will do so with multiplication. So this would be the last step. Okay, so now it's just a single log with x squared times z. So number 12, 4 log of x minus 7 log of y plus 5 log of z. So first thing is these can move back to their exponent spot for each. So this would be the same as the log of x to the 4th minus the log of y to the 7th plus the log of z to the 5th. And then remember what I said, anything that is positive goes on the top and anything that is negative goes on the bottom. So this is going to look like when you put it together, the log of x to the 4th and then y to the 7th goes on bottom, but then z to the 5th goes back on top because of this plus sign. So notice, anything with a plus sign goes on top, anything with a negative sign goes on bottom. So this would be your final answer. All right, so the change of base formula, just make sure that you know how to do the change of base formula. So the change of base just says that if you have the log base b of something like x, okay, that you can change it to the log of x over the log of b, or the ln of x over the ln of b. You're allowed to change the base to anything you want, but we typically use log or ln because those are on our calculator. So for number 13, if you had the log base 13 of 50, then we're going to change this into log of 50 over log of 13. To remember which one goes where, remember that the base one always goes on bottom. Okay, and if you multiply or divide that out rather on your calculator, you will get about 1.53. So on the test, I would want to see both of these answers so that I know how you got the real thing. So notice I used log, common log, for number 13, but you definitely don't have to. So let's look at this one. So let's use ln for this one. So this one could be ln of 7 over ln of 0.3. And then notice it becomes something I can plug in my calculator relatively easily. And so if you do that, you're going to get about negative 1.62. Okay, so the change of base formula is pretty simple. You just take the log or the ln of this number over the log or the ln of this number. All right, so starting with number 15, notice that I have some instructions for this little set, right? I say express each side as the power of the same base. So we're trying to use our rule where if the bases are the same in an equation, so are the exponents, okay? But notice that's not true right now, right? The bases aren't even the same. So what you want to do is you want to rewrite this as a power of 3, not a multiple of 3, not 3 times something, but 3 raised to some power. So 3 to the 4th power is what you need to get to 81. And then notice the left-hand side doesn't change, okay? But now that the bases are the same, then we can set the exponents equal to the same thing. And then we just solve from there, right? So we end up getting x is 3. So whenever possible, this is a really helpful rule. If the bases are the same in an equation, then you know that both sides of the equation, or both sides of the exponent on both sides of the equation is the same. Sorry about that. All right, so let's look at number 16. Number 16 is probably more like what I would probably ask about on test 3, just FYI. So notice that these are not the same base. Okay, so I usually have students try to be like, oh, I'll just set these exponents equal to each other and I'll be done. Okay, it'd be nice if that were as easy as it was, but it's just not. Okay, so we're going to need to actually rewrite both of these. And you need to pick a power that you can find that could be a base for both of them. So I'm going to rewrite both as a power of 2. Because I can't write 8 as a power of 4. Okay, so don't pay attention to the other exponents that we have right now. For right now, I just want you to tell me how we would rewrite 8, right? And we would rewrite 8 as 2 cubed. But then don't forget the 1 minus x power that it still has, right? How would you rewrite 4 as a power of 2? It would be 2 squared. And then again, we'll just leave our x plus 2. But then we can use the exponent power rule. So notice the power rule says we're allowed to combine a power raised to another power if we just multiply the powers. So just make sure that you distributive property here and here and here also. So this would be actually 2 to the 3 minus 3x power. And then this would be 2 to the 2x plus 4 power. So make sure the 3 goes to both things, the 2 goes to both things. But now notice that the bases are equal. They weren't before. So now we can set 3 minus 3x equal to 2x plus 4 and solve from there. So I'm going to add 3x to both sides, and I'm going to move the 4 over this way. So notice I'm going to get -1 equals 5x. And so if I divide both sides by 5, I get x equals -1/5. Okay. I haven't been mentioning it for every problem, but a lot of these numeric problems you can check your work. So let's talk about how you would check it just real briefly. So if you think the answer is -1/5, but you're not 100% sure and you just want to check it, you just take the original equation and you plug it in both sides. So I'm going to do 8 raised to the 1 minus -1/5 power, because that's what I've got first, right? So I'm using this original equation right here. And notice that's going to give me 12.1257 blah, blah, blah. Okay, it doesn't really matter what I get. I'm really just trying to compare the left and the right side to see if they're the same as each other. So now I'm going to do 4 raised to the -1/5 plus 2 power. And notice I get the same exact decimal, right? So I checked it and we're good to go. Okay. So a lot of this test, remember, can be checked on your calculator, and I hope that you will. So just keep that in mind. So this one looks kind of janky, okay, but it is really nothing different. We're still going to want to make the bases the same, so I want to rewrite this as a power of 6. And I can do that because roots just give me fractional powers, and since it's square root, it's just 1/2. And then notice the left side doesn't really change, okay. So now the bases are equal. So I'm going to set x minus 3 over 4 equal to 1 over 2. Anytime you have a fraction equal to another fraction, you can cross multiply, meaning that this times this has to be the same as that times that. Okay. So 2 times the x minus 3 must be the same as 4 times 1. Don't forget to distribute. So we get 2x minus 6 equals 4. Slide that up. And then we will add 6 to both sides. So 2x equals 10. And then divide both sides by 2, so x is 5. So notice I could check this one too, right? I would just take the left side of the equation, plug in 5, and make sure it's the same as what you get when you plug in the right side of the equation. Okay, so let's look at the next little set. Okay, so notice I ask you on this whole set to solve for the exact answer and then also give me the approximated answer to 2 decimal places. So on number 18, notice that it's different than the problems I just finished, right? There's no way that I can write, easily at least, 17 as a power of 5, right? So I can't rewrite them. So I'm just going to say I can't rewrite as a power of 5 easily anyway. Not off the top of my head. So what I'm going to do instead is I'm going to use logarithms. Okay, so I am going to take either the common log or the natural log of both sides. That's going to be my method that I use when I cannot get the bases the same simply. So I'm going to give myself some room here. So I'm going to take the common log for this one. So I'm going to take the log of both sides. And the reason I like to do that is because the power rule of exponents, or sorry, of logs, tells me that I'm allowed to move that x to the front. So this is actually x times the log of 5. And this is still the log of 17. And so then now I can just divide by the log of 5, and notice I've got my answer. So this would be gone, and my answer, the exact answer would be log of 17 over log of 5. But if you punch that in your calculator, you'll get what's on my key, which is 1.76. Okay. So just real quick before we look at the next one, you can actually, let me show you how you enter that in your calculator. So log of 17, close parentheses, divided by log of 5. You also could have used ln, but you'd have to use ln for both top and bottom. So notice I get the 1.76. Okay. So now if you wanted to check it, you can say, okay, what is 5? So I'm going back to the beginning, or right here. What is 5 raised to the 1.76 power? And notice it's awfully close to 17, right? It's not perfectly 17 because this was an approximate answer, hence the approximately equals symbol I used there. But we can check it knowing that we got pretty close. All right, so there's a couple differences between the problem in number 19 and the one in 18. And the first thing is we have another number here, so when you have other terms kind of in your way, you need to get rid of them first. Okay? You need to isolate the exponential term. This is the exponential term, so that means the 4 needs to move over. So I get e to the x equals 21/4. I could change that to a decimal if I want, but I think it's just as good to leave it there. So I'm going to get ready to do the log of both sides. I can either use ln or log, but for e I definitely want to use ln because they're inverse operations. So not only does the x move to the front, but ln and e are opposites of each other, or actually they are inverses, I should say, and this would be 1, because this is saying what do I raise the understood e base to give me e, and the answer is 1. So you end up getting x equals ln of 21/4, which is your exact answer, and then if you put that in the calculator, you'll get right about 1.66. Okay, so once again, you can check your answer, right? You can say, okay, is 4 times e raised to the 1.66 power, is it pretty close to 21? And note that it is, right? It's 21.037, blah, blah, blah. Okay. All right, so let's look at number 20. So we have 7 to the x plus 2 power equals 410. So note, we can't write 410 as a power of 7 easily. Okay, so we're going to take the log of both sides. In this case, it probably doesn't matter which one we use. Note, it's not base e or anything like that, so I'm just going to use log, but you could use natural log also. Doesn't really make a difference. The whole purpose is with any of the logs that this is going to get to move to the front. Just be careful when you move it to the front because it actually needs to stay grouped together. So this is what you get. So when I move the x plus 2 to the front, I put it in parentheses. And now remember, your goal is to find out what x is. Okay, so I'm going to do some algebraic moves to make x isolated. So first I'm going to divide by log of 7. Whatever I do to one side, I need to do the same to the other. So that's going to give me x plus 2 equals log of 410 over log of 7. And then last but not least, just subtract 2 on both sides. So because I'm out of room, here's my exact answer. Log of 410 divided by log of 7. and then minus 2. And my approximate answer is on your key, and it is about 1.09. Okay. Know that when you check rounded answers and the numbers involved are larger, then your answer when you check it might not be quite as close as they are when the numbers are smaller. Because frankly, when you're rounding an answer, you have a small error, and a percentage error on a bigger number like 410 is going to be, you know, more significant than a percentage error on 17 or 21 like we had in the previous problems. So just keep that in mind. When you check it, it may be a little bit off, but I think it'll be close enough where you could get it. All right, so 21. The log base 5 of 2x plus 1 equals the log base 5 of 11. Okay, so notice this is the log version of our rule before, but notice that the bases are the same. And when the bases are the same on one side or the other, you can set the parentheses terms equal to each other. In other words, when you have the bases the same, what you're taking the logs of are also the same. So this is a problem that looks uglier than it actually is. It's actually just finding 2x plus 1 equals 11. So if I subtract 1 from both sides, I get 2x equals 10. Divide both sides by 2. So x is 5. That's it. Number 22. So we've got 7 plus 3 ln of x equals 6. So the first thing we want to do is isolate the log term. So I want to subtract 7 from both sides. That will give me 3 natural log of x equals negative 1. And then I'm going to divide by 3. So some of you may have been able to get here and then you were like, now what? Okay, like now what do I do? And what you have to remember is that ln is an understood base of e. So when you do the rewrite step, this is actually saying something, right? This is saying e to the negative 1/3 power equals x. And then that is something that could just be punched in your calculator. So this is the exact answer, and x is whatever you get when you do e to that power. So e raised to the negative 1/3 power, I'm going to slide it over, would be 0.72. So remember, we want to do a rewrite usually when we're talking about logarithms, and so the understood base for ln is e. All right, so 23. Log base 2 of x plus log base 2 of x minus 7 equals 3. So note here, I'd really like to rewrite this, but I have two terms. Okay, so since I have a plus sign here, I want to combine these, and you just need to decide which rule I should use. So because I'm adding, I'm going to use product rule. If I were dividing, I would use, if I was subtracting, I would use quotient rule. So this is going to look like log base 2 of x times x minus 7 equals 3. Or the log base 2 of x squared minus 7x equals 3. So this is going to look like 2 to the 3rd power, right? So I probably should mention this. A lot of times students forget this important step here. Okay, from here, you absolutely need to do the rewrite step. Okay, and that's often forgotten. So what I mean by that is it's base raised to the exponent power, right? The answer to a logarithm is always the exponent, equals what you're taking the log of. So if we move this up here, this is 8 equals x squared minus 7x. And then notice I've seen stuff like this before, right? I just need to move the 8 over and then maybe see if I can factor. So I get 0 equals x squared minus 7x minus 8. So I'm looking for factors of -8 that add up to -7. So that would be minus 8 and plus 1. So it looks like I get 2 answers, but I always need to be cautious with logs to make sure that it's not going to be invalid. Remember, it's been a minute maybe, but when we take the logs of negative numbers, we get an error on our calculator, and that is because you can't take the logs of negative numbers or 0 because you're never going to have an exponent that's going to give you this result. So this is actually invalid. Okay, it's invalid because you can't have logs of 0 or negative numbers. So the only actual legitimate answer is 8. Okay, so on a test, if there's a question like this where one of the answers gets thrown out, I would want to see where you found them both, but where you reasoned that one of them wasn't reasonable for the problem. So same kind of thing for number 24. So log base 2 of x minus 1 plus log base 2 of x plus 1 equals 3. So for this one, again, we would combine using product rule, again, because we're adding. If you were subtracting, you would use quotient rule. Then you might have to cross multiply or something. But this would be the log base 2 of x minus 1 times x plus 1 equals 3. So before I worry about rewriting, let's FOIL this. So I'm not going to do the steps of FOIL, but you should get x squared minus 1 if you FOIL. So again, don't forget this step, super, super important. If you want to change it from a log to a exponent, then you need to do it the right way. So it's base to the 3 power equals what we were taking the log of. So it's 8 equals x squared minus 1. And then we would subtract 8 from both sides. So we end up getting x squared minus 9. This is a difference of squares, right? So it factors into x minus 3, x plus 3. So we get x equals 3 and x equals -3. It's not just the fact that this is negative, it's the fact that when you plug it back in, you will be trying to take the log of a negative. Okay, so don't always just throw out your negative answers, because sometimes if you plug them in, they might be okay. Like for instance, if this were a -3 and this were like a +5 or something, if you plugged in the -3, it wouldn't have been a problem, right? You would have gotten 2 there, and that's not a negative number. But as it is, when you plug in -3, you're going to get negatives. So this one's out, leaving only this guy. Okay, so make sure that you review one that has quotient rule in it too, because that could show up on the test. Okay, and then the last exponent/log question is number 25, and then we're going to start looking at the system of equations stuff. So you have 2 formulas. P equals 1 plus r over n to the nt power, or A equals P times e to the RT power. I would give you these, but I'm not going to tell you what each of the letters stand for. So you need to make sure you know when to use these. Okay. By the way, this is for continuously compounded interest. And this is for any other time frame. Okay. So for number 25, let's go ahead and plug in what we know, right? So we know that the principal or the starting amount was $14,000. The rate is 7%. Make sure and write that as a decimal, 0.07. And then the n is always how many times per year you're compounding. Notice the problem is monthly. And if it's monthly, then n is 12. Okay, if it's quarterly, n will be 4. If it's annually, n will be 1, or some others too we went over in class. So this will be to the 12 times number of years power. So let's look at what that looks like on your calculator. If you have an older calculator, make sure that you put parentheses around the exponent. I don't need to do that on mine because it already kind of opens up an exponent box. Notice it has a cursor right here, right? So, but if you don't have a calculator that does that, make sure you put parentheses around this 12 times 8. But you should get $24,469.57, rounded to the nearest penny. Okay, so the first 25 questions of the review were about logs and exponents. And so the next video is going to be over questions 26 through 39 on your review over the system of equations problems. So that's kind of going to be the format of the test. Some logarithms and exponent questions, and then other system of equations problems.